want to do is talk a little bit about water, and one of the things that I've noticed for a long time about Phoenix is that we have a lot of infrastructure around, but most of it is pretty invisible. It's kind of hidden within our urban environment, and if you know where to look for it, you can find it, and it's quite interesting. But a lot of times we don't configure our buildings to face power lines, and we don't face our buildings so that they're on the canals, so we don't actually see where our water comes from. Has anyone ever turned on their tap and water didn't come out because the water wasn't there? Good. That means that all the city water managers are doing their jobs. It means that the federal government is providing natural resources to us. It means that we have a system that's being managed in a way that the expected result is actually what's happening. Phoenix actually has a really great aquifer underneath it. It's hard, it's impervious, so it's not spongy. The water actually stays there. And a lot of our water management is based around the concept that if you put water in the ground, it's just going to stay there. It's not going to leave. So you can come back and you can get it later. You have to have water to support that. You can't just build without thinking about, do we have enough water to grow? So the Central Arizona Groundwater Replenishment District will buy water from the Colorado River and recharge it for you. And then you can use groundwater. You can turn on a pump. You can pump your water out of the ground. And because someone else is putting in an equal amount of water that you're taking out of the ground, the system should be in balance, okay? It's in balance, but what are we spending as we do this? Energy. Every time you pump water out of the ground, it's a massive amount of energy. So I have a question for you. Why don't we just use the water instead of putting it in the ground and then pumping it out of the ground? Some of the new communities don't have surface water treatment plants. So groundwater, when it comes out of the ground, it's percolated through the ground, it's pretty clean, right? A lot of the sediment is filtered out of it, so you get pretty clean water when you get it out of the ground. So it's a good cleansing system. It's a good filtration system for water, which would also take energy if we did it. So we use energy to pump water out of the ground that we would have used to just clean the water. Okay, so again, it's another water energy trade-off that we have. So overall, what does this mean net for our system? On an annual basis, are we getting more water than we're using, or are we using more water than we're getting? Unfortunately, right now, the answer is we're using more water than we're getting.
What are the main uses of water and energy? Does anybody know? Cooling, that's right. There are, of course, a lot of issues of water in the extraction of fuels, coal, for example, or taking or importing oil. There's a lot of hidden costs of water in that. Of course, you may be aware and have read in the paper recently that an issue involving the extraction and use of water for coal is actually dividing the Hopi Nation right now in taking coal from a mine in Kayenta in the Hopi Navajo reservation and taking it to the Navajo station by Page via a water slurry. That is actually a very water intensive mechanism. There's some misconception about solar energy and water usage that is going around, that blanket statements been made by a number of politicians that solar energy uses a lot of water and therefore it's not appropriate for the Southwest. And I guess what I want to say is it all depends on what technology you're talking about to generate electricity, because some use as much as a nuclear power plant, some use no water at all. It all depends on what, and of course there's the cost issue as well. Basically, it depends on what technology you're using in terms of the water usage, and so some technologies may be better adapted to the Southwest than other technologies. And of course, if you use air cooling or other innovations, you can also mitigate the use of water in some of the steam-driven sort of concentrating solar technologies as well. There's been efforts, for example, to use corn to ethanol, or to use feedstock for corn or the waste products from agriculture to use a cellulosic-based form of energy in order to convert that to a usable fuel like ethanol. And then there are alternatives to that. There are, and a lot of work at ASU is going on using algae or microbial approaches in order to create the lipids that can be converted into fuels.